Very good morning, all of you, all dignitaries, judges, and my co-contenders. It's our pleasure to welcome you all to the 30th National Convention on behalf of DIT Electrical Department, Naval Dockyard, Visakhapatnam. Coming to our center profile, we are working under afloat submarine section, where we are dealing with nuclear and lithium class of submarines. Now, I would like to sound some of our major milestones are overhauling of 1 megawatt generator, main propulsion motor of capacity of 5 megawatt, laying of mainline cables and underwater cables, which includes pressure and gland packing, that has to maintain pressure integrity of the compartment. Any failure may lead to flooding of the concerned compartment. Also, we proudly saying that we set many footprints in the nuclear class of submarines, like overhauling of 2 megawatt turbo alternator, main motor generator, all electrical motors and panels which are related to the nuclear reactor. Let me introduce our team. Our facilitator, Commander Sunil Kumar Singh, MQA. Our coordinator, G. Suresh Babu, TA. And myself, I am a Santosh Kumar, I am the team leader. And my team members are Babuji, Srinivas, Pallai and Shivshankar. Coming to our QC profile, we met regularly on every Wednesday with an average attendance of 98%. We have identified total 82 in number of problems, in which 32 number of problems were resolved. Now we would like to present a case study titled Carbon Brush Cheater. These are the tools and techniques which are involved in this case study.
Let me present the case study that identification of problem through brainstorming. We had identified 82 number of problems and categorized it into A, B, C categories. Problem under category are 42 and 22 solved. We are 21 and 8 solved. C were 19 and 2 solved. Same is shown in the bar graph.
Our team prioritized 5 number of problems from 42 number of A category problems. They are listed out here. For the selection of problems, our team members based on the criteria is increase in productivity, ease of use, economic benefit, ease of maintenance, and safety. The quality of the product stratified the problem with the rating method with a rating factor of minimum 1 and maximum 5. Hence, problem number 2 acquired the highest marks and has been ranked as number 1. Hence, our case study is frequent failure of surface of carbon brush and brush holder. After selection of problems, an activity survey prepared for our team members in the balance of facilitator shown here.
Coming to the step 3, definition of the problem. Before defining the problem, let me brief about the DC mission. Submarine consists of 90% of the machinery are the DC mission. The main parts of the DC mission are rocker arm, carbon brush, main field and armature. The most problematic area in the DC mission is parking, and it is due to the rocker arm and carbon brushes, which is our focus now. Rocker arm and carbon brushes are the inherent parts of a DC mission. Its prime purpose is to collect or supply power to the DC mission, and these brushes are placed into the brush holder with very less tolerance and are distributed to the rocker arm. Now I would like to define in detail. Submarine consists of 5 megawatt main propulsion motor as a consumer, one set of 1 megawatt generator as a source. Both are having rocker arm and carbon brushes and are equally responsible for sparking. Any failure may lead to stall the submarine nowhere in the middle of the ocean, which leads to paralyze the national defense. To get a rough idea on the mandates consumption, we did it through matrix flow diagram. Here you can see the process starts with the pre-ticketing, which took 2 man-days. Ticketing on generator took 2 more man-days. Routines on generator took 4 man-days. Later on, replacement of new brushes took 1 man-day. Grinding and polishing took 6 man-days. Finally, rigging took 4 man-days. In total, 19 man-days are required to complete the job. This is the flow diagram before implementation. Now I would like to define core of the problem with this flow diagram. We start our work by defectation, we carry routine set on board, we replace new brushes. And these brushes are to be grinded with different bits of grinding paper to get the mirror polish. Due to this, again we are removing accumulated carbon dust. Our work instruction closes as soon as load trials are completed. This repeated cycle is continuously challenging our time and manpower, which is the very reason for our case study.
To analyze the problem, we followed 4W1H method.
What is the problem?
Frequent failure is the surface of the carbon brushes
Where is the problem?
at onboard submarines.
When it is occurring?
At the time of peak loading of the machine,
For whom it is affecting?
to both approach centers and ship shaft.
How is the problem?
For that, now I have to throw a light on a point that ship voltage ranges from 175 to 320 volt and consumer ranges from 20 watt to 5 megawatt. In the process of charging, the brushes are undergone enormous radial, axial and frictional forces. Due to this, the brushes are getting deteriorated, which leads to the poor computation, that is high sparking and overheating. The renewal of brushes and its grinding process is completely manual and backbreaking task, which has to be done in a limited oxygen zone. Now I have to specifically mention that in spite of taking acute precautions, we are inhaling carbon fumes, which leaves back our workforce with the respiratory problems. Limitation in space leads to the injuries. Chemical cleaning backed with the skin burns. Also, a new problem arriving, that is low station of the DC mission.
For a detailed analysis, we have collected data from 60 number of submarines from the past 8 years. This is the data we have collected. The collected data has been been tabulated. This is the year-wise data tabulated along with the mandates consumed. The share is shown in the bar graph. Here we could observe that the mandates consumed per system is 22.72 mandates. The impact of the problem was lack of synchronization between upload and its support centers. Repeated polishing by this shift schedule is not maintained. Then we have set our clear goal and objective. Our objective is to avoid river ease of maintenance. Our goal is to bring down the mandates to 30% and reduce the manpower by 25% and achieve the utmost customer satisfaction.
We conducted a brainstorm session to identify all the calls from each member and listed out by cause generation method. Then we obtained the log list between the cause and sub-causes and categorized into the main heads of uneven surface, parking, vibration, usage with the help of YY analysis. For the uneven surface, YY session as follows.
Why is the failure in the surface of carbon processor causing?
Due to sparking of the commutator,
Why?
due to poor commutation,
Why?
due to disturbance in MNA,
Why?
due to breakage of the edges of carbon brushes,
Why?
due to improper polishing at the time of installation,
Why?
due to constant of place and lack of time. In a similar way, we also did a vibration for the remaining main heads as shown here. From the cause obtained from the vibration, our team finally prepared the cause and effect diagram shown here. From the cause and effect diagram, we found 10 main root causes which are mainly affecting the problem identified here. Then we validated the 10 main root causes with our team members along with our department personnel and conclude the root cause analysis with 4 main root causes which are mainly affecting the problem shown here, and the rest of the 6 main causes are preserved for the future reference as shown here. And these 4 main root causes are further analyzed with the help of IWT-1 method.
How much the root cause contributing towards the problem?
For this check sheet is prepared for the data collection. The collected data was stratified and tabulated as shown on the slide. And also the mandates consumed for each root